Hey, my name's Avery, and in this video we're going to be looking at a couple different topics from this most recent unit. We're going to be looking at Rolle's theorem and L'Hopital's rule. So firstly, looking at Rolle's theorem here, this basically says it has three criteria, and if the criteria are met, it says you can find a given value C in a given interval where f prime of C would equal 0, meaning that the slope would equal 0 in that function. So the three criteria for Rolle's theorem are: is it continuous, is it differentiable, and does f of a equal f of b, which means do your different endpoints equal the same thing. So in this problem, we have f of x equals x times x minus 1 squared on the interval 0, 1. And the first thing I did was, First thing I did was expand it out. So x minus 1 squared turns into x squared minus 2x plus 1, and then you have to distribute that extra x. So your final function you're looking at is x cubed minus 2x squared plus x. And since this is a polynomial function, we know that it's continuous. And then after I expanded the function, I took the derivative of it, so this would turn into 3x squared minus 4x plus 1, and this function does exist in the interval 0, 1, so it is differentiable. That meets our second criteria. And then our third criteria is, does f of a equal f of b? In this case, our a would equal 0, our b would equal 1, since that's the interval that we're working on. And all you're going to do is plug in 0 and plug in 1 into your original function, and in this case we did f of 0, which you can see the work here, but it ends up equaling 0, and then same thing, f of 1 also equals 0. So since both of these things equal 0, that means our f of a and f of b are equal, so our third condition is met. The final thing we have to do is find the values of c that it could possibly be. And so the first step of that is to factor your f prime equation you have up here. So 3x squared minus 4x plus 1 factors into 3x minus 1 times x minus 1. And you would set both of these things equal to 0, which would give us possible solutions at x equals 1/3 and x equals 1. And 1/3 definitely exists in the interval 0, 1. And I know it's kind of tricky because 1 also would technically equal or exist in this interval since it's a closed bracket, but if you graph it, it's obviously a parabola, right? So say this is our graph here, and then like this is x equals 1, and our graph looks a little something like this. I should have had it pulled up on the computer, I'm sorry. And then it goes down or whatever. But since our derivative graph is a parabola, there's only one spot where our slope, aka our derivative, is going to equal 0, and that spot is 1/3. The next thing we're going to look at is something called L'Hopital's rule, which basically states that when you're trying to find the limit of an equation like this, where you could end up with indeterminate form, 0 over 0, that you can take the derivative of both the numerator and the denominator, find the quotient of it, and it will give you your answer. So originally, when you're trying to find a limit with a problem like this, you would do direct substitution, but if you get indeterminate form, you might try factoring it out. This prompt specifically wanted to use L'Hopital's rule, so I didn't even try the other two options. I just went right into it. So you're going to find your f prime by finding the derivative of the numerator and then of the denominator. The derivative of our numerator here is going to be 4x cubed minus 3x squared minus 2, coming from this equation right here. And then the derivative of our denominator is just going to be 1. Since the divided by 1 doesn't really do anything, then we can try to do direct substitution with our new f prime equation and just plug in 1, which is what our x is approaching. You have 4 times 1 cubed minus 3 times 1 squared minus 2 over 1, which gives you 4 minus 3 minus 2 over 1. 4 minus 3 minus 2 equals -1, and so -1 is our final answer and our limit for this problem. And I don't know why I wrote it this way. I end up having to go to the other page, but the last problem we're going to look at is also dealing with L'Hopital's rule. This says the limit as x approaches 2, or that's what we're trying to find, on the equation x squared minus 4x plus 4 over sine squared times pi x. So I flipped over, and once again we're going to find the derivative of our numerator and our denominator. The derivative of our numerator is 2x minus 4, and then for our denominator you would use the chain rule, and then you can further simplify using the double angle identity to find that your derivative of your denominator is pi times sine of 2 pi x. And then this obviously isn't going to get us anywhere, so we have to take the second derivative, which is going to give us 2 on the top, and then 2 pi squared times cosine of 2 pi x on the bottom. And then you can go in and, you can simplify that because you have 2 over 2, which would leave you with 1 over pi squared times cosine of 2 pi x. And then you can go in and substitute that 2 for your x, which is 1 over pi squared times cosine 4 pi. You have 2 pi times 2. And then cosine of 4 pi just equals 1. And so that leaves you with your final answer of 1 over pi squared as your limit. Sorry about that.